I'm glad to attend Great Summit as a speaker. Now let's start to talk about reduce redundant producers from partitioned producer. Here is today's agenda. First, I will talk about background of the issue about producer connections. Second is the solution of the issue. Third is the benchmark about the solution. And last is conclusion. Let's start to talk about the background of the issue. In Yahoo Japan, Apache Pulsar is used in many use cases. For example, notification of contents updates, job queuing, etc. Also, Pulsar is used in metrics and logs streaming pipeline. Both metrics and logs is sent to the topic from computing instances, such as IRs, paths, cars, etc. These are received by metrics or logging platform. In this case, an unspecified number of producers connect to partition topic from computing instances. It causes this issue. First, the number of producers exceeds the limit. Second, redundant producers are created per computing instances. I'll explain about first issue like this image. Pulsar has config max producers per topic. Ill-behaved clients which increase producers infinitely can make the topic producer full. To solve this issue, we introduce the config to restrict number of producers and consumers for each IP address. I don't explain about the detail in this session because it is already merged. If interested, please check this link. I'll explain about second issue like this image. When the connect to the partition topic, sometimes it has redundant internal producers. Some cases as below. First, relatively loaded producers. The number of partitions needs to be increased according to the total throughput. However, creating internal producers for all partitions is inefficient for producers whose throughput is small enough to be handled by a few partitions. Second, using single partition routine mode. A partition producer creates internal producer for all partitions. In this case, each producer uses only one partition. Therefore, other internal producers are redundant. In this session, I will talk about second one. Now let's talk about the solution. Here is the concept of solving the issue. Reduce the number of producers to use system resources like broker heap, number of TCP connections, client heap, etc. more efficiently. As you can see, each partition producer connects to part of partitions like right one. When the partition producer connects to the topic, the client can randomly choose the limiting number of internal producers and internal partitions as well. To implement, we introduce producer lazy loading feature and custom loading mode. From now, I will explain detailed solutions. First, at initialization step, a partition producer connects to only one of partitions for authentication and authorization instead of all partitions. When the internal producer is created, validate authentication and validate authorization at this topic. Second, at message sending step, partitions are chosen by message router. Each internal producer is created on the first time to be chosen by message router. Therefore, the number of internal producer depends on message routing policy, like this line. Also, we add new custom routing mode, partial round robin message router. This mode supports round robin with limiting number of partitions. Also, when producer creates by single partition routing mode, then creates only one internal producer. In previous implementation, a partition producer could connect to part of partition. It causes another issue about partition producer stats. Partition producer stats are accumulated for all partitions. Accumulating procedure supposes all the partitions have the same number of producers, like left one. Therefore, we couldn't get correct stats by partial producer like right one. We would like to get correct stats not only total producer, but also partial producer. To solve this issue, we introduce producer stats key. Publisher stats with the same value for this property are accumulated as same producer. Also, a behavior that a partition producer sets same producer stats key to internal producer. By this feature, we could get correct partition producer stats. Now let's talk about the benchmark with and without the feature. Criterion of this benchmark is here. Broker's heap usage, CPU percentage. Client heap usage, CPU percentage. Number of TCP connections between client and broker, and producer initialization time. Assumption of this benchmark is here. In this benchmark, we'll send 1 kilobyte messages with 5,000 requests per second. Procedure and variables of this benchmark is here. For now, B shows the number of brokers, and L shows the limit conf. First, run B broker servers. Second, create a producer limiting L partitions. Cause the limit conf set to only proposed one. Third, send messages for 10 minutes. And last, check stats. I tried these variables at that time. Environment of this benchmark is here. In this benchmark, each brokers and clients are run as a process on single laptop. Result of B equal 5 and L equals 3 is here. I think number of TCP connections is interesting because proposed one is less than existing one. Heap usage is here. I think client heap is important, and this is a client heap. Because proposed one is less than existing one. This proposed and existing. CPU percentage is here. I think broker CPU percentage is interesting. These are broker CPU percentage. Because proposed one has a large variance than existing one. This is proposed one. Blue line and red line has large variance. Result of B equal 5 and L equal 5 is here. For existing side, conditions are equal to B equal 5 and L equal 3. So they use the same result. Heap usage is here. I think client heap is important as well as B equal 5 and L equal 3. Proposed one is less than existing one. CPU percentage is here. Result of B equal 10 and L equal 5 is here. Heap usage is here. CPU percentage is here. I think blocker CPU percentage is interested as well as B equal 5 and L equal 3. The proposed one has a large variance. Now consider about the result. Cause the benchmark is not completely correct because it is extremely simple to run only once. For client side, the result suggests this behavior. Particularly, number of TCP connections is less than or equal to existing. Suppose a cluster has enough brokers. If we use the feature number of TCP connections is less than or equal to limit plus 1. Of course, the number of brokers is its limit. Here is part of the result. Please look at B equal 5 and L equals 3 row. As you can see, both number of TCP connections and producer initialization time are less than existing. Proposed and existing. Proposed and existing. For broker side, the result suggests this behavior. Particularly, number of running brokers is less than existing. Probably because number of running brokers depends on active topics. Moreover, CPU percentage per broker has large variance than existing. Maybe because topic load isn't distributed to all brokers. Here is the part of result. Please look at right one. This matrix shows number of topics which is loaded by broker. As you can see, proposed one is not completely distributed. The ratio is 1 versus 2. In contrast, existing one is distributed. It might cause load and system resource variance between brokers. Therefore, before using this feature, we should take care the config about limiting number of partitions, or implement smart message router while considering current load. Next, I will talk about conclusion. In conclusion, I talked about implementation of producer lazy loading and partial round-robin feature and its performance by toy example. The result suggests the feature affect to client resources and broker load. The one of future tasks is to implement the feature to other clients, such as C++, Go, etc. I'm really excited to be involved in Apache Pulsar. Thank you for your attention. My talk is all finished.